So we talked a little bit about the shape of polynomials that are bigger than degree 2. So x to the third or an x to the fourth or an x to the fifth. Well, all x squared equations look something like that. Okay? And then once you get larger into x to the third, there are sort of two different types. There's a type that comes up and levels off like that. And then there's another type that actually hits the x-axis 3 times. So the degree tells you the number of possible roots. So an x to the third could hit 3 times. Okay. Well, what about that? How many times does that hit? Just twice. So we could say this might be x equals -5, and then this is x equals 3, but wait a minute, it's supposed to hit 3 times. Where's the other one? The same as 3. It's actually a bounce. So whenever a root happens twice, the graph will bounce off the x-axis right there. Okay, well, what if I move it up even further? How many times does that hit? Just once, so where are the other two? They're imaginary. So we have one here, and then there are 2 imaginary roots over there. And we don't know what they are. Okay, but there are 2 of them. All right, and x to the fourth could look like this, like a parabola, only taller. But it could also be a W. See how that has 4 roots? And actually, I didn't like that one. Let's do this. So that has 4 roots. Now it still has 4 roots, but these 2 are the same. Now it only has 2, and the other 2 are imaginary. And now it has 1, but it's actually a bounce. And now it has none. Okay. What about x to the fifth? Well, x to the fifth could touch 5 times, or, oops, let me split these. Or it could touch 4 times, and one of them is a double, a bounce. Or it could touch 3 times, and 2 of them are imaginary. Or it could touch twice, and one of them is a double, and then the other 2 are imaginary. Or once. Okay? But an x to the fifth can also look like an x to the third. It could also be that. Or it could also look like that. And actually, it would come up and then kind of flatten off like that. Does that make sense? It just depends on what comes after the x to the fifth. Or you can build it to be whatever you want. So that's a really good question. That's actually where we're headed. If I had x plus 1, x minus 1, x minus 4, and x plus 4, that is an x to the fifth equation. Would everybody agree? It has 5 roots. What are the roots? So -1 and 1, -4 and 4, and 0. Okay, now this is a positive 1. So positive slopes go up to the right. Agreed? So if we wanted to draw this graph, we have to come up, and then down, and then up, and then down, and then up. Something like that. Okay? What if there's a -1 outside? Now it starts at the top, down, up, down, up, down. Does everybody understand that? Okay, what if it was like a +4? Now it's going to be way taller. So we're going to start, we'll go up higher, down lower, up higher, down lower, like that. Now let me get rid of some of these. It's getting hard to see. Okay. What if instead of a +4, it was a -1/3? Now it's squashed vertically. So it would be something like this, where it's not nearly as tall. And we're just going to guess, right? We're not terribly concerned about exactly what it looks like. We just want to make sure it hits the x values in the right place. Okay, let's get rid of these. Whoa. All right, what if I got rid of the plus 4 and I squared the negative 4? So now my graph is shaped a little bit differently. At right 4, I have a bounce. So this is a bounce. But I still have the other roots, except for the negative 4 is gone. Okay? To draw this, it's a positive out front. So am I going to start at the bottom or start at the top? I'm going to start at the bottom and go up. So I go up, down, up, and now what? Bounce off that. You see that? Okay. What if I got rid of this one and I squared this? So now I draw my roots. 0, 1, and 4. Those are my roots. And again, it's positive, which means we go that way. So we're going to come up. This one is a bounce. Nope, sorry. This one is a bounce, and this one is a bounce. So we come up and bounce, straight through, and bounce. Does that make sense? All right. X minus 2 squared, x plus 1, and x minus 3. And let's make it a negative 1/5. What type of graph is this? X to the 4th, so it's a W. Look. Okay. And what does the negative do? Upside down, so it's actually more like an M. Everybody know that a W would be positive and an M would be negative. So it's an M. We have a root at negative 1. We have a bounce at positive 2. And we have a normal root at 3. So it's going to look something like this. So I start from the bottom, and this is normal, bounce, and normal. So I start from the bottom, and I go, oh, and what does the 1/5 do? Makes it really short. So normally I would do something like this. Oops, I missed. But since it's 1/5, I'm going to make it much shorter. So something like this. Does that make sense? Well, you have to look at evens and odds. So odds, if the number of roots is odd, then it's going to look something like this for a positive. But a negative would look something like this. Or sorry, let me do it this way. So odd graphs, if it's a plus, then the left side is down and the right side is up. If it's a minus, then it's the opposite. Oh, I did it again. Sorry. But for even graphs, then positives look like this, and negatives look like this. And then you just have to decide what happens in the middle. Well, but it makes sense, right? As a positive x squared is going to look like this. A negative x squared is going to look like this. And so an x to the 4th and an x to the 6th and an x to the 8th are all the same. But a positive x to the 3rd looks like this. And a negative x to the 3rd looks like this. Does that make sense? So you shouldn't have to think too hard about where to start and where to end. If it's even, it's either up, up, or down, down. The up, up would be positive, and the down, down would be negative. If it's an x to the third, you're going to have a down and an up if it's positive, and then an up and a down if it's negative. Can you remember that? Okay, so if I wanted negative 2 x squared times x plus 3 squared times x minus 5. How many roots do I have? 5. I have 2 x's, so I have 2 zeros, 2 negative 3's, and 1 positive 5. Okay. Now 5 is odd, and I have a negative 2 out front. So is it going to be down up, or is it going to be up down? It's going to be up down. Left side's up, right side's down. Because a positive x to the third looks like this, but a negative x to the third would look like this. And the thirds act just like the fifths and the sevenths and the ninths and so on. So I know that the left side is going to go up and the right side is going to go down, a negative slope, right? Yeah, and the 2 makes it taller. So we put our roots. Our roots are 3, or negative 3, and that's a bounce, and 0, and that's a bounce, and 5, and that's just a regular root. And the negative makes it upside down, but the 2 makes it twice as tall. And an x to the 5th is already very tall, so that 2 is going to make it even taller. So it would look something like this. Come down, bounce, bounce, straight down. Something like that. Well, you could type this into your calculator, and well, let me show you. So negative 2 x squared times x plus 3 squared times x minus 5, and then let's do zoom standard, and this is probably going to be quite tall. Bounce, bounce, and then straight down. Okay, so if you wanted to see it, you could change it. Instead of 2, let's do something like 1/8. So this is 1/8 times everything, which is going to smash it down, and you should be able to see it a lot better. Bounce, bounce, and then straight down. See that? But I don't really care how high your y-axis is. We're not going to label our y-axis. So, this might be 100. We don't label our y-axis. We just label our x-axis. And we just care about, do the ends go in the right direction, and is every root hit either by going straight through it or did it bounce? Okay, and then the other side of it is, can you tell me what this equation is? What's the equation? It's even because, how do I know it's even? We have up, up. All right? So this one right here would be x plus 5 to the second times x plus 3 times x squared times x minus 3. Does that make sense? Okay. And then there might be a number there, but whatever that number is, it's positive. Right? Yes, but not today, and we'll actually have our calculator just figure it out for us. So there might be a number in front of there, but today we don't care. All right, what about this? So, is this even or odd? odd, and it's going to have a negative out front. How do we know that? It started from the top. Okay, so this root is going to give me x plus 4, and then the next one is x plus 2, and the next one, x plus 1 to the second, and x minus 2 to the second, and then x minus 5. Now, I want to graph this just to show you something. So, negative x plus 4, and then x plus 2, and then x plus 1 squared, and then x minus 2 squared, and then x minus 5. Oops, I missed a parenthesis. Okay, graph it. And there are so many x's, this is going to be super tall. See that? So let's smash that y-axis down. Let's times it by, I don't know, 1 divided by 200. So I'm going to make it 200 times shorter. Let's see what that does. Oops. I typed it in wrong. Oh, I still have the negative. So I need to put the negative out front. Okay, so negative 1 over 200. Let's see if that was a good number. It might have been a little bit too much. So let's say 1 over 100. Yeah, that's a lot better. Basically what I had, right? 2 bounces and 3 that go straight through. Yeah, it went up and then it came back down. So you can actually build a polynomial to be any shape you want, right? As long as it doesn't ever circle back around, as long as it's just a series of ups and downs, you can change it to pretty much look like anything you want. Yep. Yeah. Yeah, if you did like x plus 7 times x minus 7 times x plus 6 times x minus 6 times x plus 5 times x minus 5, but you would have so many x's that it would be way tall, and you need to multiply it like 1 divided by a million. And you could create a graph that just does this. And you can hit wherever you want. Okay? All right. So 3.8. There's some that we're not going to do. All right, so 3, 4, 5, and 6 you'll do. And then 7 through 14 you'll graph. And 15 and 16 you could do. And then, oh, wait a minute. Let me check the answers to this. Okay, on 17 through 22, you need to find the answers using division. So for number 17, we have x to the third minus 4x squared minus x plus 4. What could the answers be? Plus or minus 1, plus or minus 2, or 4? What do you want to guess? 2? So we put 2 in the corner. 1, negative 4, negative 1, and 4. 2 times 1 is 2, negative 2. 2 times negative 2 is negative 4. Negative 5, negative 10, negative 6. Did 2 work? No. So we try negative 2, or we try 1. What happens when we find one that does work? Then we get, so let's say 4 works, and you would say x equals 4. And then you would use this equation to find the other 2. How do you find them? You put it in the box, and then once you have all three answers, so 4 and 1 and -1, then graph it. Okay? Graph it according, you know it hits here, here, and here, and you know it's positive, so you draw the graph. Okay? So we're going to do 3 through 22 all. And yeah, 3 through 20. The first bunch is really fast. All you have to do is draw the graph. They're really quick. And then 17 through 22 will take you a little bit of time. All right. Oh, wait a minute. Hold on. I'm looking at the wrong answers. We might not want to do those. 3.8. Sorry, I was looking at the wrong set. 3.8. No, you should be able to handle it. So 17 through 22, you're going to find those roots, and then you can draw the graph from the roots. Some of them are fractions, but they're not too bad. You should be able to factor those. Okay, get to work.